Good morning. In this video, we will play with a breadboard. So let me show you where you can find a breadboard. Just scroll down. So you open a new circuit and scroll down. You have a breadboard small. We can use a small for now. Insert the breadboard in your circuit. How does that work? The breadboard is a board with already wires connected. So all these little holes, they are connected. The minus there, they are all connected together. You see this green circle? It means that those holes are connected together. So if you put a battery and a light on in these holes, they will be connected together. So you have the minus and the plus on the top of the breadboard, the minus and the plus on the bottom of the breadboard. After, everything in the middle is connected vertically. So the holes F, G, H, I, F, G, F, G, H, I, J are connected together in the column number 4 and the column number 3, etc., etc. And same thing for this one. So instead of putting a wire between those holes, they are already connected together. The wires are already inside this box. Okay, so now let's see if we can turn on a light bulb with a board. What do we need? We need a source of power, so we need the battery. Let's scroll to find the 9-volt batteries. And I will put it next to the minus and the plus of the breadboard. I will connect the breadboard to the battery. So the plus positive of the battery to the plus of the breadboard. And let me turn it red. Just by conventions, the plus is red and the minus is black. Negative to the negative. And let's put it black. So what does that mean? That means that now all those holes are connected to the plus of the battery and all those holes are connected to the minus of the battery. Let's grab a light. So search for light on the right. Let's grab a light bubble. And you can put it anywhere you want in the board and the breadboard. Okay, I put it there. So I need to connect one terminal to the plus and one terminal to the minus. Okay, now the terminal 2 is just connected to those. And this one to this one. So let's take the A15 holes and let's connect it to the minus. I make it black. And the 14 holes I connect it to the plus, to the red. So when I start simulation, my light bulb turn on because the current is going from the plus inside those holes, inside the wire, and those holes are connected to the terminal 1 inside the bubbles, coming back there, going in the black wire, and back to the battery there. So try this, that's your first circuit. Now, let's check how much current we have inside this circuit. If you remove the light search and scroll down and go grab this multimeter, and we will put it on the top there. What is a multimeter? Multimeter is a tool that will measure even amperes, voltage, or resistor. What does that disappear there? It looks like I have 2 of them. You need to connect the negative to the negative side of your bubble. You can connect it there, or you can just connect it there. That's the same thing. Oops. So I put it black. And the plus, the positive, to the positive of your bubble. I put it in red. Okay. Then they have to flip. Let's see what's happened when we start simulation. When we start simulations, we have the voltage that is inside the bubble light, the bulb light. This is not exactly 9 volts. So I let you think about why. It's very close. So there's just a little bit of voltage that is lost inside the circuit because there's some resistance inside, each wire inside the breadboard, etc. So let's stop the simulations. You can play with a different mode of the multimeter. This one measures ampere, that is the intensity of the current. This one measures the voltage. And this one measures the resistor, and this one doesn't have any resistor there. We didn't put any resistor. Let's stop the simulations and let's see if we can add a resistor to our circuit. So let me remove the multimeter. Oops. Delete this wire, and I will add a resistor. So up, scroll up. Let's take a resistor, and instead of the wire, the red wire, we can remove the red wire. We take a resistor and we slide it between the plus and this one from the light. Let's see what's happened when we start simulation. What's happened with the bubble light? The bubble light is much lighter because we have included a resistor there. Let's check with the multimeter that we can scroll down. Remember what we do? We take the negative to the minus, that's the black, and the plus to the plus, that's the red. And let's start simulation. And you see now the voltage, it's 412 millivolts. So 1000 millivolts are 1 volt. So instead of having 9 volts, we have just 0.4 volt. That's about dropping 20 times. Why? Because we have this resistor that stop the current, that decrease the speed of the current. So now the current is smaller in the light bulb and your light bulb is lighter. Okay, let's stop the simulation. Let's see. I will remove just remove the wire. I will show you what's happened. We remove the wire and we remove the resistor. What we will do now, let's remove also this wire. Okay, we are like this. Let's see when we add 3 lights. So search for light, and we will put 3 lights next to each other. Okay, like this. And the current will go now plus light number 1, number 2, and number 3, and come back. So we need to connect the plus holes to this light. The minus, so this is a red. After that, the minus to this minus to this plus, and now the current is leaving the last bulb light, and going there. That's a black. So you see the current will go plus, back, up, first light, second light, third light, and back. Let's start the simulation. We turn on our 3 lights. They are bright, but not as bright as they could be, but still. And I have a question for you. What do you think about the voltage of one of the lights? What if we measure the current on one of the lights? We try? Let's stop the simulation. Use, let's say, the one in the middle, the negative to the negative there, and the plus to the positive plus there. I know it's switch, red, and black. How much do you think we will see on the multimeter? We have 9 volts and we spread the 9 volts inside the 3 lights. Let's start the simulation. How much is that? It's about 9 volts divided by 3, about 3 volts, because the current has been divided inside the 3 lights. That's what we call a circuit with a series, a circuit in series. Did you expect that? Let's stop the simulation. If we connect this one to, let's say that's the minus, we need to do this one with the plus on this one. We start the simulation. We got about 6 volts because we are looking at the current. We are looking at the current between the first light and the second light. Yay! So we are about 6 volts. Let's stop the simulation and let's see. Do you know how we make a shortcut? Do we know how we make a shortcut? So the current likes to go where it's easy to go. So if instead of going in 3 lights, I add a wire plus between this one and this one, that's a red one. What's happened? Let's start. We did turn on until 2 lights. We shortcut the first light because the current is going in the plus Oops, is it easier to go inside 3 lights or 2 only? It's easier into 2 lights, so it's just making the little loop. So plus, up, second light, third light, and back. And you will never reach the first light because it's easier for him to just, for the current to just go in 2 instead of 3. That's what we call a shortcut. If we remove this wire and add a wire between this one and this one, what will happen? We turn on just one, we shortcut the 2 other lights. It's easier to go in 1 than to go in 3 lights. If you are still with me and still having time, I add you one circuit with a switch. So let's remove 1 light and let's remove all the wires. So we will play again with all the wires and we will connect them correctly. So what I want to do is I want to add a switch, the slide switch there. So take your slide switch and let's add it, let me think, there. Okay. And we will have the current going either in one light or the other one. So the plus of your battery, it will be connected to the common, the button on the middle. So like this, red. So my current is going in the plus and in the middle of the switch. After that, this side, the terminal 1, it will be connected to this light, and the terminal 2 will be connected to this light. And we need to have the current coming back to the minus, so the 14 is going back to the minus, and the 23 is going back to the minus. So those two are black cable. This one we can say it's red cable. Let's start the simulation. Oh, we have one light that is turned on. I can make it a little bit bigger for you. If we change the switch side, we turn on the other light. Yay! That's awesome. That's 13 minutes already. I think that's enough for today. We will speak about LEDs in another video. I hope you enjoy it. Have a great day. Bye-bye.